think I can code this high-resolution black hole gamma ray burst within 70 lines, but I can, and to a good quality. Let's see. This is going to be drawn using spiral, so we need to define how to draw a spiral. And then we are going to have to draw it in a third dimensional perspective. We're going to have to draw lots and lots of spirals. And there's also color gradients. Color brightness intensity will increase the closer to the black hole it is. And then we draw black hole and the gamma rays, which is at the poles of the black hole, and then we're done. For any of that, we have to configure. So from turtle import all, so that we can draw all of this. And from math import all, so that to draw the ellipse, and then from random import all, so that we can calculate the colors. Speed will be set to 0, so that it won't take forever. With our high turtle, that will make it a little bit faster. Color mode 255, so that we can understand the code easier. And then screen EG color, background color 0064, just to give it space. Like, although space is black around the black hole, it would actually be blue. It's slightly illuminated. We have a blue screen, not of depth, but of space. So that was a blue screen, not of depth, but of space. We're going to define the variables. So radius will equal to 180 divided by pi, or 57 point blah 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 blah. We will need that to convert from degrees to radians in the spiral defining. Then we have size is equal to 600 to set the size of the accretion disk of the black hole. Ray width is equal to 20 to determine the size of the gamma ray of the poles of the black hole. Spiral length will equal to 6. So spiral length is how many revolutions it will take for the spiral to reach the center. There's also going to be an accuracy. So it will be equal to 64. So how accurate it is. The reality is this is how many steps the code will take to draw the spiral. The class ray, no brackets for defining objects. So initialize self heading self dot turtle is equal to pair self dot turtle dot speed 0, so that the ray won't take forever to draw. Self dot high turtle, so that it will just get a little bit faster. Self dot heading heading. That's it. If I draw self length colors width ray width change, length was the segment of the gamma ray, and then color will be yellow and white. So a list. Width ray will be width of ray, and then self dot turtle dot color 255 to set the initial ray blast. Self dot turtle dot forward 200. The initial ray blast will be 200 pixels, and then after that it will increase for I in range 10, for J in range 2, self dot turtle dot with rate turtle dot color. Oh no, okay. Color. Okay, to alternate the colors. Self dot to forward length. That will be the segment width ray plus equals width change. Oh, but we don't need this line because we've defined it right here. No, that's wrong, because then this will just stay the same width when width ray changes. So this will be a new width ray plus width change. That's done for the rays. Let's see what value the ray can bring. Please don't let us down. Ray angle dot draw 40, which is the length of the segments, That's 255, 200, brackets, yes. 255, 255, 255, 192, 192, and 100. No. 255, 255, 192. No. 138. And no, we're not done. There's 8, which is the width of the ray, the initial width, and the width change. I don't think why I set that there. 8. Right. And the ray width. Oh, not that. 180 plus angle dot draw. And let's see what value it can bring to us. Nothing. Oh my! It's like it brought us no value at all. How I forgot to define angle. Angle equals to 45. As you can see, we have some magnificent gamma rays. Not a round of applause, but and I should have shut it down properly. Gamma rays completed. Now we're going to set the width to 3 because we're going to draw the black hole before we draw the gamma rays. Actually, we're not going to go that fast. We're going to teach the computer how to draw a spiral. Spiral radius, width multiplier, height multiplier. We'll start simple. So up. So for iron range, 64. The x equals w mole plus times r times cosine I divided by 10. That's so that we can make it as accurate as possible. This is based on the term pi. Mole times it's height mole. H mole times r times sine I. Okay. I am not going to go through the polar angle theorem, but that's what it is. If you don't know what it is, but you can search it up for yourself. And then go to x, y. It's not a spiral. It's actually just an ellipse, and it's just a fancy equation to draw a circle. So spiral 101, 1, and we just have a spiral like that. Boring. What about 0.5? Still boring. Right. Well, the trick here is to set R is to reduce the radius every time it draws. See? It goes spirals towards the center. That's how spirals work. To set how fast it spirals towards the center, we are going to create a variable called radius reducer. So the radius divided by spiral length times accuracy divided accuracy times spiral. So we haven't defined spiral length or accuracy, and we also haven't defined spiral yet. So this spiral is just a boolean of whether this radius reducer will actually reduce the radius, because this function is going to be dual purpose with drawing the black hole as well. And we don't want it to spiral for the black hole, we want it to stay a perfect circle. So spiral will be a boolean, and then the R spiral length will be spiral length accuracy. So accuracy will be here. Accuracy because it's going to be 64. And then radius reducer. Now let's see what it could bring now. Spiral 101, 0.5. That's spiral length will be 6. Yeah, 1. And then accuracy will be accuracy because we have defined it before. Accuracy 64. and then spiral is boolean. Oh, we will set it to true because I want it to spiral. Oh, great. Not again. Ah, for goodness sake. Great. We have a spiral. So that's a job well done. Now we are going to implement the tilt of the spiral. So that's we're going to set this variable to perspective angle. Here, this we are going to use a little equation to determine the rotation. We need to convert the perspective angle to radians because math functions cosine is in radians and sine takes radian values. So we need to convert IO approximation for theta is equal to perspective angle divided by radian, which converts it from degrees to radians. We're going to make it convert with the equation x times cosine I0 plus y times sine I0, and then I believe is y negative y plus x. Nope, negative x plus y. There we go. Oh, nope, incorrect. It was right. It was right this way. Because this is nope. X is always negative on that side. Y is always positive. Oh, no, we don't need this. Y is positive for the y coordinates. X is negative. This is how you define a rotation. Right. Now let's see if this has failed us. Great, it didn't. It actually spiraled in with a great, nice perspective. So that is the perspective bit done. But now we have to draw lots and lots of spirals. So we're going to set the with spiral size to size to 600, and then the spiral length will be spiral length, and then we have a oh, I must have messed something up. Ah yes, here we haven't defined how long it will spiral for, so we need to set a variable called length, which will determine how long the spiral will spiral. Initialize spiral length times accuracy. Oh, I've done a minus sign. Well done, me. So we'll set that to length instead, and this is actually spiraled in the middle. So we're starting slowly but surely to resemble the black hole. Now we need to also set the initial position because we want to draw lots and lots of spirals at different positions. So we go to set here init. So here init length plus init. We're going to draw 64 spirals. So for IO range accuracy, spiral size by 0.545 spiral length. Nope, we're not going to draw 64 spirals just yet. We haven't defined the colors because I don't want this to take forever. So we're going to abort. We're going to ask the input to take a color and a gradient because so the color will be the color that this will be set to, and the gradient will be how fast the color turns into white. Let's move this here as a structure. Color is equal to list color. This is yes, we need to set the color. So the color will be int color 0, int color 1, int color 2. Oh no, I messed it up. This will not be the last time I mess something up. Maybe it will be, but The reason why I say this is because the color function cannot take in between values. Where on a color mode of 255, it has to be a whole number. So that's why I asked them also to be separate values. So I actually don't need this anymore. So for I arrange 3, if color I is smaller than 256 minus gradient, color I plus equals gradient. So that says it's guaranteed that it will never exceed 256. Even if it's 255.999999999, the rounding of the Python for integers always means that it will round down. So it will take the floor. And that's not going to happen. That will be it for that. Now we have to define the mechanism for here, because we need to divide the accuracy times 64, which this value now equals 1, but if this changes, this will also have to change. So if the number of times the loop this will run, this will have to change as well. We'll set the initialize to 0 and the color to blue. Error. Yes. I messed it up. It's the other way around. Oh, again. Are you kidding me? Something wrong. Let's set the color gradient to 1. Oh, this means I have to be missing some value. So, yes, 0. Are you kidding me? This is the last time I'm going to get an error. Let's actually bother to see what this would be. Yes, I was just giving a random thing, but this will have to be. This is going to have to be red, green, blue values. So 0, 0, 64. Tuple object is just. All right, then I'll make it to a list then. Nice try this time. I diffused all your errors. Boom. As you can see, this is starting to look pretty nice. Now, what we are going to do is the moment of truth for I range accuracy. RGB is equal to randint. Nope. 0 randint 0 16 and a randint 4880. Now, the moment of truth. What? Not yet the moment of truth. All right, not yet. We have to abort this for the last, because otherwise things might go wrong. We need to draw a central black hole first, because fill color black. Begin fill, because I don't want this to take forever. Spiral 10 1 1, radius 10, width multiply, height multiply 1. So angle so that it will be 45 degrees. 0.5, so they will only draw half a circle. 0, 0. The initial position will be 0. The color will be 0 0 0 for black. So it has to be RGB, not a string. Why? I feel like that. Gradient will be 0. I don't want it to turn white, otherwise it will turn a white hole. 630, I care about accuracy for this, because it's such a small object. And we don't want it to spiral at all. That's not happening. So it's false. It's just going to be the same thing to business as usual. 0.1 and Not angle, but angle plus 180. Let's see if the hole appears. Doesn't. Must have missed something there. Ah, yes, again. I make the same mistake many, many times. I am in the habit of putting RGB values in tuples, where I should be putting them in black brackets in this case. It's going to take a painfully long time because it's such a small object, but if you are patient enough, it will appear. And I forgot to fill. I don't need to wait it to finish. And fill. Hopefully all my anger will be gone when I see that the teeny tiny semicircle appears on the screen. How long is it going to take? 5 seconds more? Ah, yes, the black hole appeared, which means we are fit to continue with the moment of truth, where we see the beautiful accretion disk that we've all been waiting for. And I've done this in 68 lines, which is less than the limit of 70. I'm going to make some final checks to see if everything's right. Seems like it is. And done. We just got an error for the first time. Uh, Consistent use of tabs and spaces in indentation. Yeah. King. I think there's a problem. No, something wrong. I've meant to forgot to change the initial position from 0 to I. I meant it to be an I. Let's try again. Let's see if something works this time. By setting the parameters to 40, it will make the process of creating this shape twice as fast. I have completed a challenge of being able to code this amazing black hole gamma ray burst in 70 lines with high quality code. Now, you can go check out how I coded the solar system. That's all